Hello guys, welcome back. So today let's try to understand what is recursion. Okay, so let me quickly zoom in the screen so you guys can see the definition. I hope you guys can see it clearly. So it's a smaller definition and then we'll try to understand like what is it. Okay, so recursion is a technique to solve a certain problem by like creating a function that calls itself. Okay, so when somebody asks you recursion, what is recursion? The first thing which should come into your mind is it is some sort of a function which calls itself. Okay, and to illustrate that, let me show you an example. Let's say you have created a function x. Okay, so how we can make this function recursive? Okay, so normal functions you call like this, right? You call like this, but the recursive function you call inside. Okay, so as you can see, this is a function which is calling itself inside of it. Okay, so this is what we call a function is calling itself recursively. Okay, so that is what we call recursion. Okay, so it basically is used to break down bigger problems into smaller sub problems and then to solve them. Okay, very easily, right? So now let's see a few examples like how we can make use of recursion. Okay, so let me I think it's already commented, right? So yeah, so let's say you have an array of some numbers. Okay, let's say 234 and then 488 and then 456 and then 200. Okay, so now you want to find the odd numbers within this array. Okay, what you will do without recursion is you will simply iterate through the array. You will find the index of 1 is index of 0 is the odd number. No, then you will move on to the next number. Then you will check if it is odd number. No, then you will move on to the next number. And then you will see if this one is odd. No, then you will move on to the next number. Okay, so basically simply like you will use a for loop or some sort of loop to iterate through each elements, and then you check whether it is what to say, like even number or not, odd number or not. Okay, but with recursion, how we used to check it, we simply remove the first element. Let's consider like in recursion we are going to check only the first element. Okay, instead of checking the big array, like that this big array, this giant array contains the odd numbers or not, we simply check whether a particular single number is even or not. Okay, so we break down into simple problems. So okay, so let's say in recursion how we used to pass it, we used to pass say let's say this number. Okay, we are going to check only the first number if it is even or odd. Okay, so here we will check, just forget about rest of the elements. Here we will check first number is even or not. It's sorry, it is odd or not. It's not odd, right? It's even number. So we will remove it from the array, right? And then in the second iteration or the second function call, we'll simply remove that particular number. Okay, and then again we will check whether this first number is even, odd or not. Okay, so it is also not odd, it is an even number, so we will also remove this number as well. Okay, so let's paste it here and then we'll remove this number. Okay, now again we are going to check whether this first number is odd or not. It is also not odd, so we will simply remove this number as well from the array. Okay, now since we have removed all the numbers, we have just one number left, and on every function call we were just checking the first number only, right? So we were not messing around with the rest of the numbers. Okay, we were just worrying about whether the first number is odd or not. If it is not odd, then we were simply removing it, and even if it is odd, then also we will remove it. Okay, now in this array we just have one number. Okay, and again we are going to check if the first number is odd or not. If it is not odd, then we are going to remove this number as well again. Okay, so now let me remove this. Okay, so now we have an empty array, right? As you can see, we have an empty array. So in this empty array we will check if the first number is odd or not. since we have no number, we can write an edge case at the beginning of the function. Like if there is no length, then return false or true, right? Since there is no number itself, then obviously it is going to return false only, right? There is no odd numbers. So this is how recursion works, right? Instead of looping through the whole array, we basically check one number and we basically check whether it fits in our conditions or not. Okay, based on that, based on our problem statement, we used to manipulate it, add or subtract it, or like we do the operations whatever we want with just single number. Okay, so this is one example like how we use recursion. Now let me show you another example. So there is a so-called problem statement which says like factorial, right? Where you have to pass a number and then you have to get the factorial of that number. Okay. So let's see like how we can implement that with the help of recursion. Okay. Let's say factorial. I think I spelled it wrong. Okay. So factorial, right? So here you have to pass some number. Okay. Let's pass number. Okay. So in factorial, what happens, like first condition we have to put is like if the number is 0, okay, then we have to return 1 every time, right? So we'll write the condition if num equals to or triple equals to 0, then we simply have to return 1. Okay, now let me call this function here first. Okay, factorial, here we'll pass the number. Let's say I want to get factorial of 5. Okay, before that, let's check what is the factorial of 5. Okay, 5 factorial. Okay, it's 120, right? So it is giving me 120. So let's see, we can implement that or not with the help of recursion. So here what I will do, I'll simply call this function. Okay, so instead of running a for loop, what I will do, I'll simply call this same function inside. Okay, and here what I will do, I'll simply subtract this number every time by 1. Okay, so this is first step. Okay, and then what I will do, I'll simply multiply this number with whatever I get from here. Okay, so this is the idea, and don't worry, like first let me run it and then I'll add the console logs. Okay, so as to show you like how this thing actually works. Okay, now let's first see whether it works or not. I hope it's running already. Okay, I'm getting some error somewhere. Oh, because of this thing, right? I have to comment all these things. So let's quickly add a comment here. Okay, so now we have a function ready. So let's see how it goes. Oh, sorry, this thing I have to pick, right? 5 factorial. Okay, so it is giving me 120. And by the way, congratulations guys, just now you have built a function which is working recursively, right? Even if you didn't understood like how it is working, how it is giving me 120, I got your back, I'll explain you. Okay, so here you are getting a number. Okay, so what we are doing, we are calling the same function every time by decreasing a number by 1. Okay, so let's say here you have called a number, let's say 5. Okay, now again you are calling that function. Since the number is not equals to 0, this if block won't get executed, right? So forget about this if block for now. Okay, now what about this one? Okay, so what is happening here, every time you are passing let's say 5, you are again calling that function with one number decreased in the original number. So this time it will become 4, right? Then again it will go through all these conditions, like if the number is greater equals to 0, no, then again it will call the same number. Right now we have 4, 1 will get decreased in 4, now it will become 3. Again it will go inside this logic. Okay, and then it will check if it is equals to 0, no, then again it will call this number. Okay, so let me add the console log. And guys, one more thing I wanted to tell you, whenever you are using recursion, make sure to handle the edge cases. Okay, otherwise it can easily crash your browser window. Okay, it can run infinitely. Okay, So that is the thing. Let me show you quickly because I again have to restart the window, I think. So let's say I'm commenting this thing out. Okay. Now, if I run this function, I have to quit it again, but that's fine. Okay. Now, if I run this function, it will, okay. So it started giving maximum call stack size exceeded, right? That means it ran like more than the maximum size of the call stack. Okay. So that is what you have to keep in mind. So it can run infinitely, right? So it called so many times, like it crashed our window and it started throwing the error like the maximum call stack size range exceeded. Okay. So this is what happens. Okay. So that is why you have to make sure like you are handling the edge cases. Okay. Before making a function recursive. Okay. So where I was, yeah. So we were seeing the console logs, right? So let's see what is a number which we are getting. Okay. Number here. Okay. So number. Okay. Now here you will get to know like how it is getting decreased every time. Okay. How we are getting the like what to say uh, one smaller number every time. See, every time we are getting 5, 4, 3, 2, 1, right? How we are getting it? Here we have passed 5. We have called this function with 5, right? Now here we are simply checking if the number is equal to 0. No. Then again it will call this function, right? And here what we are doing, we are simply decreasing a number by 1. Okay. So until it reaches 0, it will keep on calling our recursive function, right? It will keep on calling our recursive function. Okay. So that is how until it is reached to 0, we are getting like 1, 5, 4, 3, 2, 1. Okay. We will get 0 also if we add this log before this if condition. And let me show you that as well. Okay. As you can see, here we are getting 5, 4, 3, 2, 1, 0. Right. Now, since the number is equals to 0, we are returning 1. Okay. Otherwise, what we were doing, we were simply multiplying that number with the like whatever we are getting in the return, right? So let's see this thing as well. Okay. Okay. I added this before the like if condition, so I apologize for that. Okay, I should write it somewhere here, right? Okay. So now, as you can see, let me quickly stretch it a little bit. I think I need to comment this console log, right? Factorial value. I'll write here. Okay. So here what we're doing, we are simply console logging the same output, right? Whatever we are getting here. Number you have already seen, we will get 5, 4, 3, 2, 1 because we are subtracting number by 1 every time we are calling this function. Okay. And then we are multiplying that number with whatever we are getting in return from this factorial num minus 1. Okay. So here. Okay. So factorial value, we are getting num let me quickly stretch this thing. I think this much will be fine, right? This much will be fine. Okay. So what is happening right now? Num, let's say here we are getting, let me quickly log this as well. Okay. Because this way you won't get the idea. So here we'll see like what we are getting in the factorial value function return. Okay. Okay. So as you can see, function return value, we are getting 1. Okay. Function return. Let me just filter this thing out only. Okay. So here, as you can see, function return, in function return, this one, we are getting like we are getting ones, and then in between we are getting somewhere 2. and then somewhere we are getting 6, and then again 2, again 2, and then 24, 2, and then 6. Okay, so this way we are getting the function return value, right? Now let's see what we are getting in the factorial value. Okay, and then I'll tell you like how it is working. Okay, so here let's see like what we are getting in the factorial value, right? So here we are returning 1, obviously it will return 1, so we are getting 1 like most of the times, and then we are getting 2 somewhere, and then we are getting again 2, 6, factorial 2. Okay, so this way we are getting some console logs. Okay, now let's see how it is working. So let's say let me quickly wrap it in actually the comments. Okay, because I don't want it to keep on calling the function, right? So let's say you have called function factorial 5. So what is the logic which we have written? We have written basically if you are passing a number, okay, so it will be something like 5 into like factorial of 4, right? Factorial of 4. Okay, so now in factorial of 4 what will happen? And why we are calling factorial 4? Because whatever number you are passing, we are decreasing it by 1, and then we are calling that function again, right? So now in the second function call, we will have factorial like 4 as a number, as a parameter, right? So now what will happen? We are simply calling it like this. Okay, 4 into factorial of 3, right? Now in the next iteration or next function call, we will have 3. So here it will be 3 into factorial of 2. Okay, because of this thing, I hope you guys understood by now. Okay, so here it will be 2 now, 2 into factorial of 1. Since we are getting 1, so it will call the function one more time until it gets 0, right? Now 1 into factorial of 1 minus 1, 0, right? So if we are getting 0 here, at this point we will get 0, right? So it will return 1. Okay, so it will return 1. Now 1 we are trying to multiply with the number which we are passing, right? So the number which we have passed is 1, right? Here, just see closely. This thing is so annoying, guys. Okay, so here we are returning 1. Okay, so since we are returning 1, so it will get multiplied to the number which we are passed here, right? This one. So this one will get, let me move it here, multiplied with this one. Okay, now this part is clear. Okay, so this thing is CLR, let's say. Okay, so this thing is clear now. Now what, like it will move on to the last call, function call, right? Where we are multiplying whatever we are getting in return from this function to whatever number we have passed earlier, right? So that means this function, this whole thing, this factorial 1 have returned us 1, this thing, right? Now what will happen? Since it is returning 1 into 1, this thing, let's say. Okay, so now this 1 into 1 will get multiplied by 2, right? Since it is the return value of this factorial, right? So now what will happen? In this function call, we will get 2 into 1 into 1. Agree? Now this is the return value. This is the return value, as you can see here. This is getting returned from this function call, right? This factorial, basically this one. Okay, so now since we are calling this factorial here, when we are calling the factorial of 3, okay, so this is going to be the return value of this factorial, right? So let's add it here. Now this is the return value of this function, and we are again multiplying it by 3. Okay, so let's add it here. So as you can see, it is getting built slowly, right? So now this is the return value of factorial 3. Okay, and again factorial 3 was called when we were checking the factorial of 4, right? Okay, So now since this is a return value of this factorial, this thing, we are going to multiply it by 4, right? Here in this case, because the factorial 3 is returning this whole thing, right? So now we are going to multiply it by 4. Okay, so this way we are going to multiply it. Okay, so now till factorial 4 we got our value. Now let's see about factorial 5. Okay, now this is the value of factorial 4, right? This 4 into 3 into 2 into 1. Okay, this whole thing is the value which is returned from here for the function call of this one, right? Factorial 4. Okay, so since this function is returning us this value, okay, because of this line, now like we are going to use this thing here, right? And then here, as you can see, we are multiplying it by 5. Okay, sorry, I have pasted again. So 5 into 4 into 3 into 2 into 1 into 1. Okay, so this is what we got in the final like function call. Okay, and then if you multiply this whole thing, you will get factorial of 5, which is 120, right? So this is how the like what to say recursion works. Okay, and if you are still confused, like after returning this function, how it is calling the older function along with the previous value, then for that you have to understand about the call stack. Okay, how call stack works and how the function calls get executed. Okay, so basically I'll give you a like high level overview. So let's say you have called 5 functions in a row. Okay, one function inside of that, another function inside of that, another function inside of that, another function. Okay, say in this same fashion. Okay, so what will happen, like this function will get executed, the function which is at the top of the call stack will get executed, its execution will get execution context will get pop off. Okay, and then the function which was called prior to it, let's say this one will get executed, its execution context will get pop off from the call stack. Then this function will get executed, its call stack like its execution context from the call stack will get popped off, and then this one, and then this one. Okay, and at the end it will return us some value. Okay, so yeah, this is how like factorial, or this is how the recursion works in a nutshell. Okay, so this is a simple example. Okay, we'll talk about different types of examples of recursion, and before that we are going to understand, like we are going to have a look at the call stack. Okay, because as you can see, now we do need to look at the call stack, like how call stack works with the help of this recursion, right? Then only this example will get crystal clear. If you already know about call stack, then it's well and good. You guys might have understood already like how it is giving us like these answers, right? So now this is it for today's lecture. Let's look at the call stack and let's try to understand a recursion a little bit more, and then let's try to see why we need recursion, right? This is the question, because in this video I have just explained what is recursion, how we can write a recursive function, right? So now in the next lecture, let's see why we need it, and then let's look at the call stack, okay, to understand it a little bit better. So by the way, I'll attach this snippet whatever I have wrote here in the description of the video. If you want it, you can get it from there. Okay, so this is it for today. See you in the next one.